Alright, we got a little video here on rationalizing denominators. And why we want to rationalize the denominator. Sometimes we can have a fraction, say something like 5 over the square root of 2. And we like to have things here where we don't have something like a radical in the denominator. It's easier for us to work with and everything. So what we want to do here is we want to rationalize that. We'd like to get rid of that denominator. And if you'll remember from converting fractions and such, if we can multiply this by something to get rid of that. And we want to multiply, we essentially want to multiply by 1 because we don't want to change the value. However, we have to multiply by 1 in a different form than the number 1. What we're going to have to do here is, since this is a square root of 2, we know from past experience square root of 2 times square root of 2 is 2. So if we multiply this whole thing by 1 in the form of the square root of 2 over the square root of 2, that'll clear the radical out of our denominator. And what we'll have is 5 times the square root of 2 over, well, the square root of 2 times the square root of 2 is 2. So this is how we rationalize a denominator. Let's look at another example here. Let's say we had something like 2 over the square root of 7. Well, to get rid of that square root of 7, we're going to multiply everything by the square root of 7. And we get 2 square root of 7 over 7. Okay, let's do a couple more. We'll do at least one more here. Let's do this. Let's do the square root of 5, the square root of 8. So again, we're going to multiply both top and bottom by the square root of 8 over the square root of 8, which gives us the square root of 40 over 8. Now, we can simplify this numerator. We know that's the same as the square root of 4 times the square root of 10 over 8. So really we're looking at 2 times the square root of 10 over 8. And we can simplify this more because our 2 and our 8 we can factor out. So we have the square root of 10 over 4. Okay, so rationalizing denominators, if it's a square root, we're just going to multiply the whole thing by 1 in the form of the denominator over itself here. Okay. So let's look at one more simplification here. In this case with rationalizing a denominator, or how we can work through these things. And this really, let's just do the problem. So we want to simplify this problem. We have 12 minus the square root of 18 over 9. Okay. So at this point, I think that we don't have a radical in the denominator. We're not doing anything there. And you might think, well, we got a radical in the numerator. Do we need to rationalize that? Well, let's see what happens. Let's simplify this square root of 18 first. We have square root of 18 is equal to the square root of 9 times the square root of 2. Well, again, the square root of 9 is 3. So the square root of 18 would be 3 square root of 2. So we can write that here. We can say this is the same as 12 minus 3 square root of 2 over 9. Now, can we simplify this? Well, yeah, we sure can. We can rewrite this expression here in this manner. 12 over 9 minus 3 square root of 2 over 9. In this case, we can look at this and we can factor here. We can factor a 3 out of both 12 and 9, which gives us 4 thirds. And we can factor a 3 out of here and here, which gives us 3 and square root of 2. So really, we're looking at 4 minus the square root of 2 over 3. So, we didn't have to rationalize anything here, but what I'm saying is we can work through problems without having to do that all of the time necessarily. So it's a good thing to be able to look at a problem and analyze it and see what you have to do in these cases. So rationalizing denominators, remember, if we're in a square root, something like 1 over the square root of 2, we're going to multiply everything by whatever that denominator is over itself, because square root of 2 over square root of 2 is equal to 1. Square root of 7 over square root of 7 is equal to 1. 1026 over 1026 is equal to, everything over itself is equal to 1. So we look at this and think that's how we do this, so we can get a denominator without a radical. So if we have to get to a situation in an expression or an equation where we have to combine like terms and we have a lot of fractions, we can get rid of these radicals in the denominators and work through the problem. So hopefully this helps with rationalizing denominators. We'll be talking about Pythagorean theorem next. Have a good one. Bye.